Strip away the drywall and a modern home stops looking like a building. It looks like an engine. Beneath the paint sits a hidden network of respiratory, circulatory, and structural systems. If an engineer got just one calculation wrong, the house will slowly destroy itself from the inside out. Here is how a modern home actually stays alive. Every modern house is 7 interconnected systems built on top of each other. When one fails, the others feel it. When one is built poorly, it compromises everything around it. Most homeowners know their house has a roof, walls, and floors. What they don't know is what is inside those walls and beneath those floors, and what those systems are actually doing every single day. Today we go through every one of them, what they are, how they work, and what you need to know. Here's what surprises me most about homeowners. They can tell me their mortgage rate and what their countertops are made of, but almost none can tell me what their house is made of structurally, how water moves through it, or where electricity enters. Nobody teaches this. You get handed a key and a handshake. That is the full education. People who understand their home systems catch problems early. They know what a strange sound means, what a new crack indicates, and when to call an engineer versus a plumber. That knowledge saves thousands of dollars. Let's fix that gap. System by system. Behind this wall is the structural system, the skeleton your house is built around. In timber-framed homes it is studs, plates, diagonal bracing, and beams transferring every load from the roof down through the walls into the foundation. In concrete or masonry, load-bearing walls and columns form that path. The principle is the same. Loads travel downward through a deliberate hierarchy. Interrupt it, remove a load-bearing wall, notch a structural member, frame an opening incorrectly, and you compromise everything above. I see this regularly. A homeowner removes what looks like a simple wall. 18 months later the ceiling sags, doors stop closing, and cracks tell me exactly which structural path was broken. This system cannot be guessed at. It requires engineering before it is touched. The foundation anchors the structural system to the earth, and it is the one thing homeowners think about least, until it fails. Foundations do 3 things: transfer loads into the ground safely, resist soil pressure laterally, and act as a barrier between ground and structure. When any one of those functions is compromised, the consequences work upward through every floor and wall above. What undermines foundations is almost always water and soil. Unmanaged water changes soil-bearing capacity, and clay soils expand and contract with moisture in a cycle that physically moves the foundation. Tree roots follow moisture, and roots that find a crack will widen it. A foundation communicates long before it fails, in cracks, movement, doors that change behavior. Reading those signals early is the difference between a manageable repair and a catastrophic one. Every house has a waterproofing and drainage system, a hierarchy of barriers, each designed to catch what the layer above it missed. Outermost is the cladding that sheds most rain. Behind it is a drainage cavity managing any water that gets past. Behind that is the wall structure, which in a correctly built home should never get wet at all. Below ground, the damp-proof membrane beneath the floor slab, external waterproofing on below-ground walls, and perimeter drainage carrying groundwater away. When it works, you never think about it. When it fails, a torn membrane, a blocked drain, an incorrectly installed flashing, water finds the path of least resistance. And water is extraordinarily patient. It works through any gap for years before you see it. The electrical system steps power from the grid down to usable voltage, distributes it through circuits, and provides protection that interrupts flow when something goes wrong. At the entry point is the main switchboard. From there, circuits run through wall and ceiling cavities to every outlet, light, and appliance. Each circuit is protected by a breaker rated for the maximum current it is designed to carry. What most homeowners miss: the electrical system degrades invisibly and dangerously. Connections loosen over years of thermal expansion. Cable insulation deteriorates in cavities exposed to heat or moisture. Circuits adequate when the house was built become overloaded by modern demand. Warning signs: outlets that feel warm, breakers tripping occasionally, flickering lights under load. Every one is worth investigating, because the failure mode of an electrical system is fire. Plumbing is 2 systems in opposition. The supply system delivers clean water under pressure to every outlet. The drainage system removes waste through gravity, using calculated pipe falls to ensure flow never reverses. The supply system operates under constant pressure every hour of every day. One joint weeping a single drop per minute causes serious moisture damage inside a wall before it is ever visible on the surface. The drainage system relies entirely on correct pipe gradient. Too shallow and solids deposit. Too steep and liquids outrun solids. Below-slab drainage incorrectly graded during construction is one of the most expensive defects in any new build. Accessing it means cutting through your finished floor. HVAC, heating, ventilation, and air conditioning, most directly affects how comfortable and healthy your home is. It is also the most poorly maintained system in the average house. A correctly designed system manages air pressure, controls humidity, filters particulates, and introduces fresh outside air regularly. A poorly maintained system does none of these adequately. HVAC is a sealed system that accumulates contamination. Unchanged filters allow particulates to build up on heat exchanger surfaces. Ductwork incorrectly sealed during installation leaks conditioned air into wall cavities rather than the rooms it was designed to serve. From an engineering standpoint, HVAC interacts with the thermal envelope, structure, and waterproofing simultaneously, which is why problems in one system are frequently connected to problems in another. The thermal envelope is the system most homeowners have never heard of, and the one that determines how much energy your house consumes. It is the boundary between the conditioned inside and unconditioned outside. The insulated walls, ceiling, floor, and every window, door, and penetration through those surfaces. The goal is to make that boundary as thermally resistant as possible. The thermal envelope fails almost always at junctions and penetrations. A perfectly insulated wall loses its effectiveness the moment there is an uninsulated pipe penetration, a poorly fitted window reveals, or an unsealed gap at the ceiling. These thermal bridges bypass the insulation entirely. Understanding the thermal envelope explains your energy bill in a way no energy provider will ever tell you. 20 years of structural engineering has taught me this. Every system is designed to function independently, but they all fail together. Water entering through a failed waterproofing system migrates into structural framing and rots it, destroys wall cavity insulation, and creates the humidity that corrodes electrical connections. One ignored leak becomes a structural, electrical, and air quality problem simultaneously. A structural system moved by foundation settlement does not just crack walls. It misaligns doors and windows, breaking waterproofing seals. It distorts HVAC ductwork. It stresses plumbing joints into the slow weeping leaks nobody finds until the wall is opened. Your house is not a collection of independent problems. It is one integrated system. When you see a crack, a stain, a door that sticks, ask which system is communicating and what it is telling you about the systems connected to it. Walk around your house once a year. Look at the foundation for new cracks. Check under every sink. Test every door. Shine a torch along the ceiling. Look at the roofline from outside. 30 minutes. Caught early, problems cost hundreds. The same problems 2 years later cost tens of thousands. Know your systems. Walk around your house. When something changes, act on it. Every house you will ever live in has these 7 systems running inside it. Most people spend 30 years in a home and never truly understand it. You now know more than most. Share this with any homeowner or anyone about to buy. Comment below. Which system in your home do you understand the least? I'll cover it in a future video. Subscribe. See you in the next one.